Hello friends, today we are going to discuss about the one DSA problem pre-order to BST. Let's read the problem statements. Here given an array of n nodes representing the pre-order traversal of the some BST. You have to build the BST from the given pre-order traversals. The pre-order traversals, the route made is visited before the left child and right child nodes. Okay, here given a problem test case 40, 30, 35, 80 and 100. This is a pre-order traversals of a binary search tree, and we need to make BST by this array. Okay, here you can see, here in a pre-order traversals, first node is 40 and after that we go to the left, then node is 30 and after that we go to left, but here is null, and after then go to right, then 35 and after that we go to right side. Okay, so uh, problem statements, we have given this arrays and we need to make the BST. Okay, and in the second problems you have a second problem statement test case. Okay, this is the array of the pre-order traversals and we need to make the BST. Just in a BST we have a node, and at the left all nodes of the root node are smaller, and at the right side all the nodes are greater than the root nodes. Okay, let's explain by a example. Here let's take a test case 1. Here example 1, 40, 30, 35, 80 and 90. This is the examples. Okay, now we need to make a BST. First we start from these nodes. Now 40 is a first nodes, and after that we go to left or right, and in the left side all nodes will be smaller than the 40, and you can see from here to here all nodes are less than 40, so 30 and 35 will be this side and remaining this will be right side of these nodes. Okay, and now again we will make another nodes. Here first node is 30, then at this we will search here 30 will become this nodes. Now this side will be the less than of 30, but here only present 35, so here no node will be present in the left side, and right side there will be present 35. Okay, no any elements are remain, so at the left and right all will be null. Now just try this. Here first element will be the node, and after that left or right, left side will be the lesser elements of 80 here, but no lesser elements are present here, so here will be null, and bigger elements will be make the nodes. No, only one elements present here, so this will make a nodes, and here left side no any elements are present, so left will be null, no elements present, so right will be null. Now final structures will be look like this: 40, 30, 80, here will be null, here this will be 35, here will be null, here will be 90. This will be our BST. Okay, this will be our final results. So we need to make from this array to these structures. Okay, let's take one other examples. You will be able to more clear. Just take examples here. n is equal to 8 and values 40, 30, 32, 40, 30, 32 and 35, 80, 90, 35, 80, 90, 100, and last element is 120. Last element is 120 and n is equal to 8. Okay, now first elements will be node, so then we make nodes, and below all elements lesser than the 40 will be go to the left side. This will be go to the lesser than the 40 will be go to left side, and bigger than this all elements from here to here go to the right side. Now first elements will make the nodes. Now this will becomes the current nodes, here this will becomes current nodes. Now go to find the left and right, so below 30 will make the left nodes and above 30 will make the right nodes, but in this areas no element lesser than 30%, so this will become null, or here 32 and 35. Okay, no, in this will becomes node. Now find the left and right, here no elements lesser than the 32, so left will be null and the right will be this. Here this first node will becomes the node. Now left and right no elements present, so left right both will become null. Okay, here now make this sides trees. left and right. No elements lesser than 80%, so left will become null. No, right. In right side there will be 90, 100, 120. Okay, now first will become node left, right. No elements lesser than the 90%, so left side will become null and right side become 100 and 120. Okay, now first elements will become node, now left and right. No elements lesser than, so null. Here becomes 120 and this becomes node. Okay, this side and this side null because no elements remains. Okay, so we can see the final structures are look like this: 40, 30, 32, 35, 80, 90, 100 and 120. This is a final BST structures. Okay, let's implement this by code. Okay, here we will be edit code. Here we make return solve functions. They gives me our root nodes of the BST. Okay, we pass the preorder traversals arrays, then we pass the first index and the last index of this array. Okay, now we will make these functions. Here we pass the starting index, then this will be the ending index. No, you can see if the starting index greater than ending index, then we have no elements. Okay, then we will pass return the null. If st greater than starting index will be over the ending index, then no element will be present in the array, so we will return null. Okay, now we will make a node. One new nodes, we will make one new nodes. Okay, nodes data is equal to first data will be the becomes the nodes. Okay, and if st is equal to end, this means if arrays presents only one elements, then we will just return these nodes. Okay, no, if st lesser than end, then we need to find the this index, because this becomes a node and we will need to find this index, because of we will split these elements for the left and these elements for the right, so we will find this index. So for this we pass this index and this index with this values, and traverse until array elements are lesser than 40. If array element are greater than 40, then we can say this index is needed. Okay, int index, find index. For this we need to pass pre and st plus 1 and ind and first index. Okay, now we recursively call the left and right. Left we pass pre, we start plus 1 and index minus 1. Okay, and it recursively call solve. Here also solve. Pre, here starting index will be the index and ending index will be the end. Okay, now node left will be left. Now here nodes left values added with this left, and node right will be right. Finally we'll return these nodes. Now we need to write these functions. Okay, let's write int find index. Let's pass all these parameters and values. Let's start the index with I is equal to st, I go to end. Okay, if val is lesser than pre, we will break the function and return that index. Okay, now let's run this. Now you can see this is correctly run. Now let's again summarize this. First we make the solve functions, they return the root of BST. Here we make the solve functions, here passes this pre-order traversals arrays and starting index, ending index. If starting index greater than ending index, it means arrays contain no any elements, then we will return just null. Then make one new nodes and we set the values as the first indexed values. Okay, then if st is equal to int, it means if arrays contain only one elements, then we just return that's nodes. Now if array contain more than one elements, then find the index to iterate left side or right sides, because left side contain all elements lesser than the node values and right side contain all elements greater than the node values. So these functions have to find that index, and then we pass this index to find the left BST, and now here pass the index to find the right BST, and then we set node the left is equal to left and node the right is equal to right, and then return the nodes. Here's to find index we will pass as the pre-start index, end index, and the values which is until values are greater than the nodes, then we continue, and if values are less than the array value, then we breaks and return the index. You can submit it. Okay, here we have successfully submitted. You can see also here, by this you can understand more clearly. Here first nodes will become first elements will becomes the node, and we find the index till now, because at the left side all elements are lesser than the 40, and at the right side all elements will be greater than 40. That's why we need to find this index. Now we will recursively call these functions and recursively call right for these elements, and that's why we will find all elements. Okay, you can see and write these codes by yourself. Thank you.